Alright, so one issue that we have is getting the position and IMU data to a number of different controllers. So it all comes from this microcontroller here. This is a 9 degree of freedom board with barometer on board. And that's fine, but the problem is that we have a number of devices that all need the same position information. The board here is an I2C host, so our master device. So using I2C was kind of out of the question since we'd have to have two masters on the same bus, and we didn't want to get into that. So what we've kind of set up is a polling system in which the IMU is connected, its serial receive is connected to the GPS, which this is our dummy GPS board, and the transmit on the serial is connected to a number of other microcontrollers, any of the microcontrollers that need data from it. So to request data, there's a multi-pin header here. These are just GPIOs. You can see there's pull-up resistors on it right now. There's 6 channels, so there's 6 different requests that we can make to the board. So by bringing these pins high, we can request different pieces of data. So some of them are just IMU data, some of them are just GPS data, some of them are just temperature data. There's some that are combined, different combinations of that. So this is kind of a way around the serial limitations of the microcontrollers, since there's only one serial port on each board. So we can try this here. Got the serial monitor open, and I can put it in a place where you can see it there. So in order to poll the device, I'm going to bring that pin high with the resistor to the 3.3 volt line. So this is a poll request for the GPS sentences. So you can see that kind of bouncing because I'm just touching the resistor. It maxes out at a multiple maximum requests, 3 requests. So if you try to request more than 3 pieces of data at once, or without bringing the pin back to low, it will time out, essentially. Kind of to stop devices from spamming it by just holding the pin high constantly. So the idea is the other devices will bring the pin high, and then as soon as they get data back, they'll bring the pin low again. So we can do this, that's the GPS, normal GPS sentences. We can also do this over here. This is just a segment of the GPS sentences. We've got the time, the latitude and longitude, and altitude there. So, so we have another one here. We have this. This is kind of everything, all put into one big string that's sent down the line. And you can see at the beginning of the line there's a letter and then some brackets. So that letter at the beginning of the line indicates the type of data that's being received. So the idea here is that when a device requests a particular type of data, if another device is requesting the same amount of data, the same type of data at the same time, the request could be fulfilled by one single response. Also, since there's multiple requests that can be made and there's only one serial line going out, we need to distinguish requests from one another.